Hey guys, in this video, we're going to discuss Leetcode 325, the maximum sized subarray that having the sum equals to k. So basically for this problem, we're going to have two input parameters. One is an array of numbers, and then the target value k, and we need to find the longest subarray in this numbers array that having the target value of having the sum equals to target value k. So again, this is a subarray problem, and as I have discussed before, so for subarray problems, the most common algorithm we're going to use is a running sum map. So basically, this is how the running sum map algorithm works. So if we have so we're going to keep track of the current sum from index 0 to the current index, and then store it in a map. So let's say if the current sum from index 0 to index I is 10, and then if there is a sum from index 0 to index j is 7, and j is smaller than I, then we can know for sure from index I to j, the sum will equals to 3. That's basically the main idea behind the running sum map algorithm, that how it works. So in this problem, we're going to also use the running sum map algorithm to solve this problem. So we're going to keep track of a running sum map where the key is the sum from index 0 to index I, and the value will be the earliest index for this sum. Because for this problem, we want to find the longest size of the subarray. So that's why we need to have in the index as the earliest index for this sum, so that when we subtract from j to I, like the j to I, the size will be maximized, like the length between the number of elements between index I to index j will be longest. All right, so let's walk through this algorithm to see how it works. So let's say the input is like this numbers array, and the k is 3. Like we need to find the longest subarray that having a sum equals to 3. And we initialize the map as 0 to -1, which means for sum 0, the index is -1. That's because like if we do select nothing, like if we have the sum from 0 to I is already 3, and then like we don't need to subtract any subarray from the current subarray. So basically, like index 0 to I is already 3, the target equals to the target. Then like the subarray will starting from index 0 to the current index I, right? So that's why for sum 0, we keep track, we initialize it to -1, so that like if we want to subtract 0, like we just subtract nothing from the current subarray. Okay, so this is initialized for the running sum map. So now let's see, the first number is 1, right? And then the current sum, running sum will be 1. So the value we need to subtract to get 3 is -2. Do we have -2 in the map? Nope. That's why we do nothing. And then we need to update the map. So let's say that 1 will equals to 0 because it's index 0. Now we move to the second number, which is -1. And the index will be, let's check of the current index as well. Current index equals to 1, right? Previous index, this is index 0, and this is index 1. And then the current sum is 0. And we need to subtract 3 to, the value to subtract is 3 to get to the target 3, right? So does -3 in the map? No, that's why we do nothing. And now we need to update 0 to, 0 is already there, so we do nothing because we need to keep track the value of the in the map. The value of the in the map is the earliest index for the sum. So we already have -1 for sum 0. So we do nothing here. Now we have the next number, which is 5. And the index is 2. So the total sum from index 0 to current index is 5. And we need to subtract 2 to get to the subarray. So do we have 2 in the map? No. And we do nothing. And now we need to update 5 to index 2, right? So which means the earliest index to get a sum of 5 is index 2. Now the next number is -2, and the index is 3. All right, and the current sum for this one will be 3, and the value we need to subtract to get 3 is 0. So do we have 0 in the map? Oh, yes, we do. So now we need to update the length of the subarray, which is current index 3 minus the value -3 here, which is the length is 4, right? So the maximum length we have up to for now is 4. And now we need to update the current sum is 3. So we update it in the map 3, and the index will be 3. Now we move on to the next number, which is 3. And the index is 4. The total sum will be 6. 3 plus 3 is 6. And the value we need to subtract is 3. Do we have 3 in the map? Yes, we do. And the index is 3, right? So the length is like 4 minus 3 is 1. So the length of the subarray is 1. But is it maximum? 1 and 4, the maximum is still 4. So we keep this unchanged. So the maximum length is still 4. All right. And now we reach the end of the array, and we find that the maximum length is 4, and this is what we need to return. So yeah, so the output is 4. So basically, this is how we're gonna solve the problem, and this is I just walked through that. So let's try to code it out. All right. So yeah. So first we need to initialize the few variables. The current sum, which is 0, and the running sum map. Running sum map, which is dictionary, and then we need to initialize it with index with sum 0 and equals to index of -1. Now we need to loop through the algorithm. Oh, okay. We also need to keep track of the maximum length. This is what we need to return. Return max length. So now let's loop through the numbers. Since we need to keep track of the index as well, so let's loop through the array with the enumerator of the array. So for index and the number enumerate the numbers array. So the current sum implemented with the value number, and then the value to subtract. Value to subtract equals to the current sum in this case. Okay. So now let's see if this one exists in the array or not. If this one is inside the map, if this is inside the map, then we need to just get the maximum length, right? So the current length would be just equals to the current index minus the list sum for this value. Update the maximum length. The maximum of the max length is the current length. Oh, sorry, this current length. Now this is like if it doesn't exist, then we do nothing, right? And we also need to update the running map. So we only update it if the current sum doesn't exist. So if current sum, because we need to keep track of the earliest index. So if it's already there, so we do nothing. So we only update if it's not there. In, then for the current sum equals to index, right? See how it goes. Should working fine. Yeah, looks good. So yeah, so the time and space complexity. So the time complexity is linear order of n because we just loop through the array one time, and the space complexity is order of n as well because we have a map for that. Okay, so this is the end of the video, and I'll see you guys in the next one.